Hey guys, welcome back. So today what we're going to be looking at is the distance between 2 points located on the Cartesian plane. To do this successfully, we're going to calculate the distance using the distance formula. So vocabulary words for today to define in your books will be Pythagoras' theorem and the distance formula. So I'm actually going to show you now how this distance formula was derived using Pythagoras' theorem. All right, so first of all, let's start off with Pythagoras' theorem. So we know that if we have a triangle here, right, so we're going to find the length of each of the sides using that formula a squared plus b squared equals c squared. Okay, so for example, let's take this triangle that we have here and we're trying to find the length of this particular line, this red line here that's going through point A and point B. So what we need to do, we need to work out the length of each of the sides. I'm going to call this side A, I'm going to call this side B, and I'm going to call this side C, and we're always going to have C equal to our hypotenuse. So first of all, let's work out this length here. Now looking at our Cartesian graph, we can see that the length of A here is going to be 3, and we can see the length of B is going up to 4. So we could simply write this as 3 squared plus 4 squared is equal to C squared. Now all we have to do is just rearrange. So I could write this as C is equal to the square root of 3 squared plus 4 squared. So if I just chuck that into my calculator, I know that this answer is going to be 5, but let's go through. So 3 squared is 9, so square root of 9, and this 4 squared is going to be 16. So C is going to be equal to the square root of 25, which is going to be 5. So now what I'm going to do is I'm going to show you how that's actually been used to develop the distance formula. So previously when we've used that formula, C squared equals A squared plus B squared, we just substitute in the values and we just rearrange until we get whatever value it is that we want, whether that be A, B, or C. Okay, but if we have a look over here, this formula here, this is how we find just the length of the hypotenuse, which is the square root of A squared plus B squared. Now, if we have a look at my diagram here, what I've actually done is I've labeled this line here going along the x-axis as A. So I'm actually going to treat this a little bit differently. Rather than calling this A, I'm actually going to call this point here. So this point is at 0, 0, and I'm going to call that x1 and y1. And then I've got this point here, B, and this point B is at 3, 4, and I can write this as my x2 and my y2. So if I wanted to find this length along here to here, this actually becomes the difference between these 2 points, because this x-coordinate down here is actually the same as the x-coordinate along here. It's only the y-coordinates that's changed. So I could still just label this as x2, right? So if I wanted to find the distance from here to here, what I could do is I could do A is equal to x2 take away x1. Now I'm going to do the same thing with B. So this here, this point down the bottom here, again, this is the same coordinate as this point here. So this is the same coordinate as y1. So if I wanted to find the difference, or if I wanted to find the length of this line up going from here to here, I could write that as y2 take away y1. So let's substitute that into our distance formula equation now. So I've got C is going to be equal to the square root of A squared plus B squared, where A is equal to x2 minus x1. So let's pop that in brackets. So x2 minus x1, and remember we've got to pop that squared up the top there, plus y2 minus y1 squared. So that's how the distance formula is ultimately derived, right? So it's just an alternative to Pythagoras' theorem. If you find that a little bit tricky to remember that formula, that's okay. I want you to go back to basics and I want you to just use Pythagoras' theorem. Because all you're really doing is you're just pretending that this is a triangle and you're finding or using that information to find the distance of this particular line here. The really cool thing about doing things on a Cartesian grid is that you're always going to be able to create a right angled triangle. So you're always going to be able to use Pythagoras' theorem. All right, so let's go through and let's see how we actually use this distance formula now. So we've got this in nice big writing so we can see. So find the distance between the points A and B in the figure below. Answer correct to 2 decimal places. So as you can see, I've got this formula down over here. So I'm going to do my working out over here. So first things first, let's write our formula. So the distance of the two lines is going to be equal to the square root of a, which remember was x minus x squared, plus b squared, which remember was y minus y squared. And now what I'm going to do is I'm going to substitute in my points. So this point here we can see is going to be at -3, 1. So let's call that my x1 and my y1. And then I'm going to have this point here. So let's make sure we label that. This point here, b. So that's going to be at 3, 4. So b is going to be at 3, 4. And we'll call that our x2 and our y2. So again, we're just going to pretend that this is a right angled triangle, and we're going to use that information. So we're going to use this distance here squared plus this distance here squared to find the distance here squared. All right, so let's do that. Let's substitute that in. So d is going to be equal to the square root of, let's do this in brackets, 3 minus -3. So when we minus a minus, remember that becomes a positive, squared, plus, now our y2 is going to be 4, so 4 take away 1 squared. So our distance is going to be equal to the square root of 6 squared plus 3 squared. So we can chuck that all in our calculator at once, but I'm just going to do it the long way. 6 squared is 36, 3 squared is 9, so that's going to be equal to the square root of 45. So that's not going to be a nice answer. So what we're going to do, just going to chuck it in our calculator, square root of 45 is equal to 6.71. All right, there we go. So that's how we find the distance between 2 points using the distance formula, which remember is just derived from Pythagoras. And again, if you don't like this crazy formula, that is absolutely fine. Just go back, and what I would actually do is I would actually draw in, okay, I would draw in your two lines, right? And I would make that actually look like a triangle, like that. And then you can see, so the distance from here to here is going to be 1, 2, 3, 4, 5, 6. So that distance along there is going to be 6. This distance here is going to be 1, 2, 3. And then we can just use Pythagoras' theorem. Okay, so then a squared is going to be 6 squared plus 3 squared. And we already know that the answer to that is going to be 6.71. Okay, so I want you to have a go now at this particular question here. Okay, so I'm going to give you time to pause the video. I'm going to go through, I'm going to do the worked example, and then you guys can have a go at the rest on your own. All right, so let's jump in. I'm assuming you've gone through and you've practiced that question. So let's use this distance formula now. Let's make sure that we're labeling our points. So we can draw this if you want to draw this, just so you can sort of see what's going on, but I'm just going to use the formula. So the formula is going to be that the distance is equal to the square root of, remember, a squared was our x2 minus x1, and our b squared was our y2 minus y1. So our distance is going to be equal to, now x2, let's call this is our x2, and this is our x1. So this is going to be 3 minus -1. So remember, when we do minus a minus, it becomes a positive. And then we're going to have y2, which is -2 minus 5 squared. Okay, so the distance is going to be equal to the square root of 4 squared plus -7 squared. When you put this in your calculator, make sure you put it in brackets, because otherwise your calculator will read that incorrectly. So that's going to be the square root of 16 plus 49. So that is going to be equal to the square root of 16 plus 49 is 8.06. All right, I should probably put that other thing in, shouldn't I? So that's going to be the square root of 65. There we go. All right, so I want you to have a go now, practicing using the following points. So I'm going to get you guys to just do every second one. So A, C, E, G, and I. Now these last couple, these ones are completely algebraic. So you're not going to be able to get a number solution for it. All right, the last thing that I want you to have a go at is we're going to do some problem solving using this distance formula. So I will actually draw it for this one. So I'm going to pop up a graph. Just give me one sec. All right, so I've just gone in and I've just quickly have drawn this triangle for you. So we need to prove that these 3 points are the vertices or the corners of an isosceles triangle. So an isosceles triangle is a triangle that has 2 sides that are the same length and 1 side that's going to be a different length. So really what we're trying to do, we're trying to prove that 2 of these sides are the same length and that 1 of these sides is a different length. So just looking at this graph, I'm going to assume that AC is going to be equal to BC. That's going to be my guess. And then obviously AB is therefore going to be the different length. So let's go about proving this. So first, let's find the length of this line here, A to C. So let's use our distance formula to do that. So remember the distance formula is going to be x2 minus x1 squared plus y2 minus y1 squared. All right, so let's substitute in those values and let's find our solution. So I'm going to go, this is going to be my, let's call this my x1 and my my y1. Let's call this one my x2 and my y2. So please make sure that you label those. You will mess it up if you don't label them correctly. Okay, so x2 is at -1. So -1 minus 1 squared plus y2, sorry, y2 is -3. So -3 minus 1 squared. So this distance here is going to be equal to -2 squared plus -4 squared. And again, just remember when we're doing this, we need to make sure these are in brackets when we put them in our calculator. So this is going to be equal to 4 plus 16. So D is going to be equal to the square root of 20. I'm not actually going to go in and find a value for that. I'm just going to remember that this length here, A to C, is going to be equal to the square root of 20. All right, let's go through and let's do the same working out now, except we're going to do it for the length B to C. So I'm going to pause the video here and I'm going to just do this working out just to show that they are the same length. All right, I've just quickly gone through and I've done the working out for the length BC. So again, all I've done is I've gotten my formula, I've substituted in those values and I've gotten my answer. And again, we can see that this answer is going to be the square root of 20 here. Okay, so that's a good sign. We thought that AC and BC were going to be the same lengths, which they are. The last thing that we need to prove is that we need to prove that the length AB is actually different because an isosceles triangle, remember, only has 2 sides that are the same length. So let's quickly pop in. Let's find the length for AB. So I'm going to pause the video here and I'm going to do it off camera and come back. All right, so just gone in and I've just found this last length here, AB. So I've just substituted in those values to find that this length is equal to the square root of 8. So we know that AC, so in other words, this length here from point A to C is equal to the square root of 20. We also know that the length BC is equal to the square root of 20. Lastly, we know the length AB is equal to the square root of 8. Therefore, the triangle ABC is an isosceles. There we go, done, and that's our proof. So we were required to prove that ABC was an isosceles triangle, and we did that by showing 2 sides were the same length and 1 side was a different length. All right, so I'm going to get you guys to do something similar now, except what I want you to do is I want you to do this with some trickier questions. So we've got another example here with a triangle, okay, and it's telling you that triangle ABC is an isosceles triangle. So think about what that means in terms of this point here and what these potential values of A could be. The other thing I want you to have a go at is this one here with the parallelogram. Okay, now parallelogram is a little bit different to a triangle, so some key information for you for the parallelogram is you're going to have these 2 sides which are parallel to each other and the same length, and these 2 sides which are parallel to each other and the same length. We also know with parallelogram, the opposite corners have the same size. Okay, so these corners as well are also going to be the same size. And if I was to bisect this, so in other words, if I was to cut this point in half, right, I can also do the same thing going in the other diagonal. So it's going to cut it directly in half. And this is because this is a regular parallelogram. All right, so have a go at those problem solving questions and good luck. Have fun. Bye.